Today's topic is potentiometer. So guys, you know how to measure EMF of a source or potential difference across a circuit element using a voltmeter. An ideal voltmeter should have infinite resistance so that it does not draw any current when connected across the source of EMF. Practically, it is not possible to manufacture a voltmeter which will not draw any current. To overcome this difficulty, we use a potentiometer which draws no current from it. It employs a null method. The potentiometer can also be used for measuring of internal resistance of a cell, the current flowing in a circuit and comparison of resistance. Guys, you all know voltmeter is used to measure EMF, but voltmeter should have infinite resistance so that it does not draw any current when connected across a source of EMF. To solve this difficulty, we use potentiometer. It employs a null method. The potentiometer can also be used to measure of internal resistance of a cell. So what is the function of potentiometer? It is used to measure EMF when the current flowing in a circuit and comparison of resistance. Now show description of a potentiometer. Here is a figure of potentiometer. The potentiometer consists of a wooden board on which a number of resistance wire, usually 10, of uniform cross-sectional area stretched parallel to each other. In shown in figure, we show it is a potentiometer. This is a wooden board, and in parallel connection, it is a resistance wire. The wire is a magnet or nichrome. These wires are joined in series by thick copper strips. In this way, these wires together act as a single wire of length equal to the sum of the length of all wires. The end terminals of the wire are provided with connecting screw. It is connected to screw, and the nichrome and magnet wire are stretched with each other by copper. Okay. A meter scale is fixed on the wooden board parallel to wire. This is the meter scale. A jockey, a sliding connecting maker, is provided with the arrangement. It makes a knife edge contact at any designed point on a wire. Jockey has a pointer which moves over the scale. This is jockey. It determines the position of the knife edge contact. In figure, 10 wire potentiometer is shown. A and B are end of the wire. K is jockey and S is a scale. Jockey sides over rod C and D. Okay. So what is jockey? It is sliding connecting member of this arrangement. What types of wire used? So magnet and nichrome, and they are attached with each other by copper wire. Okay, and one scale is also attached. Here it is a scale and it is a jockey sliding between C and D. Okay, so this is the arrangement of potentiometer. Now measurement with a potentiometer. Let us suppose that the steady source of EMF is connected across uniform wire AB of length L. Wire AB ની length કેટલી છે? L. Positive terminal of the accumulator is connected at end A. A steady current I flows throughout the wire. The potential difference across AB is given by V is equal to IR. VAB, potential difference VAB is equal to IR. If R is the resistance per unit length of the wire, K is potential drop across unit length, then R is equal to small rl, and EMF E is equal to KL, then K is equal to E by L. The length L of wire potential drop is given by V1 is equal to KL1, K is equal to E by L. Put K's value EL in V1 is equal to KL1. We will get E by L into L1. The potential falls linearly with distance along the wire from the positive to the negative end. We wish to measure an unknown voltage. The positive terminal of the cell is connected to end A. Here, A is connected to positive cell of connected positive, and B is connected negative terminal through a galvanometer to the jockey having variable contact Y. Okay. Shown in figure. Here, A is connected to positive of cell and B is connected to negative. Here is a galvanometer is connected. Okay. This is the description of potentiometer. V, note that the V greater than E, it will not be possible to obtain null point. So we use a standard cell of EMF E bracket E's value, EMF's value is greater than voltage. Okay. This is the arrangement. The measurement with potentiometer have following advantages. એના advantages શું છે આપણે જોઈએ potentiometer થી measurement. When the potentiometer is balanced, no current is drawn from the circuit on which the measurement is being made. When potentiometer is balanced, then no current is drawn. Okay, it produces no change in condition in a circuit in which it is connected. It produces not change in condition. It makes use of null method of measurement, and the galvanometer used need not be calibrated. This is the three advantages of potentiometer. Okay. Now the last topic, drift velocity of electrons. Let us now understand the microscopic picture of electrical conditional in a metal. The model presented here is simple, but its strength lies in the fact that it conforms on Ohm law. We assume that the metallic solid consists of atoms arranged in a regular fashion. Each atom usually contributes free electrons, also called conduction electrons. The electrons are free to move in the metal in a random manner, almost the same way as atoms or molecules of a gas move about freely in the container. It is for the reason sometimes conduction electrons are referred to electron gas. The average speed of the conduction electron is about 10⁶ meter per second. હજુ કોઈ કંડક્ટર છે એમાં જે ઇલેક્ટ્રોન હોય એ ફ્રીલી મૂવ થાય, એની સ્પીડ કેટલી છે 10⁶ meter per second. We know that the current flows throughout a conductor is the absence of electric field. If the electric field is absent, then the current flow. Because the average velocity of a free electron is 0, on an average the number of electrons moving in x direction is same as number electron moving in x minus direction. There is net flow charge in any direction. Okay. Now the acceleration. is equal to E into E by M, and if tau is the average time between collection, we can write the expression the velocity of Vd is equal to E into E by M into tau. Now I is equal to Ne minus Ne AVD. Vd is equal to drift velocity. Vd is equal to E by M into tau. Put the value. We will get I is equal to minus ANE square E by M into tau. Okay. Since electrical field is negative spiral gradient of potential, E is equal to minus dV by dr. We can rewrite the expression I is equal to plus NE square AV by M tau by L. Then V by I is equal to R is equal to ML NE square tau into A. Okay guys. And the combined result rho is equal to 1 upon sigma M NE square into tau. Okay. So there are this all is different. These are description about potentiometer. Okay guys.